Algebra 2 Common Core, Unit 4. This is 4-1, so this is the first lesson in Unit 4, and we're talking about parabola characteristics. So we're going to spend a couple of days discussing parabolas and what exactly is a parabola. So here's your definition for a parabola. It's a set of all points equidistant from the point called the focus and the line called the directrix. Let me just discuss this briefly for a minute. So what we're saying is now equidistant. Now you know that if I were to discuss all of the points equidistant from a point. So, let me label all the points that are, X units away from this. Like let's say that however far these two dots are. Let's pretend it's, 5 units, whatever. Um, what about all the points that are 5 units? Well, this is all 5 units, also 5 units away. This is also the same distance, same distance, same distance, same distance, same distance, same distance. And what am I slowly creating here is I'm creating a circle. If we look at the circle, by definition, all the points, and this is pretty terrible. Actually, that's not that bad. But all the points on a circle are equidistant from the center. So a circle is a collection of points. These are just like we know, like a line is made up of a collection of points, right? But a circle is a curve, which is a collection of points equidistant from a single point. So that's what a circle is. It's a group of points the same distance from a point we call the center. But what a parabola is a collection of points equidistant from a point and a line. So first, here's a line. And I said, all right, give me all the points that are the same distance from this line. Like this point is a distance away. Well, so is this point, so is this point, so is this point. All these points are equidistant from the line. And in fact, they're also over here. All of these points are equidistant from this given line here. So this is actually a concept called locus, and we don't really, talk much about that name anymore, but we say the locus of points, which is just the collection of points equidistant. So the collection of points equidistant from a point is a circle. The collection of points equidistant from a line is a parallel line on both sides. Well, what about the collection of points equidistant from a point and a line? So let me turn this little circle into a point here, and so let me fill it in black. And so the collection of points equidistant from a point is a circle. The collection of points equidistant from a line is a couple of lines. Well, what about points that are the same distance of a line and a point? Like, give me a point that's the same distance between these. Well, this point right here, right in the middle, right smack in the middle, that's the same distance to this point and the same distance to this line. But where else? Like if I go off to the side here, the problem with this point is it's closer to the line than it is to this point. So it actually ends up curving a little bit that I'd have to kind of go up a little bit, almost like I'm going circular around the point, but I'm not going exactly like this point is equidistant from that point and this line. And this point is equidistant from the point and the line. And I could even get one, it's probably going to be a little further out though, maybe somewhere like this, equidistant from that point and this line, meaning this is the same distance. But then, like, going further, like, up here, it would be, I don't curve then around, like, it wouldn't be over here, because then I'm closer to the point than I am to the line. So it ends up going, like, out here, where this distance equals this distance. And I end up with the same thing over here, these points over here. That this point is the same distance here as it is here, and this point is the same distance, and this point, and this point. And what we're doing is we're drawing a parabola. A very sloppy parabola, is a collection of points that are the same distance to a point and a line. The point we call the focus, and the line is called the directrix. And so you don't need to draw any of this stuff. I probably should have mentioned that. I'm going to go back to this page in a second. But all of these points here are the same distance. Every point on this parabola is the same distance to this focus as it is to this directrix. The one that we started it with, right in the middle, that's the vertex of the parabola. The turning point, the minimum, or if we're upside down, it's a maximum. So that's what a parabola is. All right, let me go back to our worksheet here. So a parabola, you've been working with parabolas for years. And you did a lot of it in Algebra 1 and probably a little bit, in 7th and 8th grade talking about parabolas. But I don't know if you ever learned exactly what a parabola was. It's a curve, but what makes that curve? It's all the points that are the same distance to a focus point and a directrix line. So the focus is a point on the axis of symmetry. Now this is using the phrase axis of symmetry. So let's talk about the axis of symmetry. And this is probably a term you're familiar with, that a parabola is symmetrical, meaning you could draw a line right smack down the middle of it that makes it a mirror image of itself, a line of reflection where it would fold onto itself. That's the axis of symmetry. The vertex is on the axis of symmetry, and so is the focus. The focus and the vertex are both located on the axis of symmetry. So it's a specific point that is what creates the parabola. Like if this point was further up here, or then this parabola would look a little bit different, because then these points would have to be shifted a little bit to be equidistant from that point and this line. And the directrix is a specific line, and the directrix also has a relation to the axis of symmetry. It's perpendicular to it. In this case, the y-axis is acting as the axis of symmetry. I'll just say AOS, axis of symmetry. And the directrix is perpendicular to that. All right, now the axis of symmetry, there's an equation you learned probably in Algebra 1, maybe before that, that we could get the equation of the axis of symmetry by doing x equals negative b over 2a. Now the reason why it's x equals is because it's a vertical line. And vertical lines have no, I shouldn't say no slope, they have undefined slope. You know, if you do the slope formula here, y minus y over x minus x, your y's would be different, but your x minus x would be the same. They'd both, you know, so it'd be 0. You'd end up with a fraction over 0, and that's undefined. So a vertical line doesn't have a y equals mx plus b format. It's just x equals. Like x equals 3 would look something like that, where it's crossing the number 3, a vertical line at 3. If your equations just have y equals, like y equals 3, that's a horizontal line crossing 3. Remember, the variable that you have is the axis that you cross. So when you do have y equals mx plus b, like y equals, you know, 2x minus 3, you're going to cross both axes because you have both variables. But if you just have an x, you're only crossing x. If you just have a y, you're only crossing y. But the axis of symmetry, negative b over 2a, and these a's and b's are the same thing that we see like in the quadratic formula, because a parabola is in the form ax squared plus bx plus c. So negative b over 2a, that gives you the axis of symmetry vertical line equation. And then the vertex can be found from that. Now the vertex is the maximum or minimum point on a parabola. It could also be referred to as a turning point. And the axis of symmetry, as we said earlier, the vertex is on the axis of symmetry. So whatever the x value of the axis of symmetry is, that's the x value of the vertex. And then we can plug that x value into the function to get the y value that goes with it. I'm going to do an example of this to show you what I mean here. But first, let's draw a parabola. So given the focus of 1, 3, and a directrix of y equals 1, draw the parabola. So I want to draw all the points that are the same distance to these two things. The easiest is the vertex, because it's right smack in the middle. Then I got to find other points that are the same distance, and the next easiest points, sometimes the only ones you could get after this, are the ones that are directly to the sides of your focus. And you kind of say, all right, you're trying to basically make a square. And right here you can see that this point is 2 to the right of the focus, and it's 2 above the directrix. And then the same thing can be said over here. 2 to the left, 2 above. And so basically, what's the distance of the focus directrix? Since it's 2, go 2 on both sides. If this distance was 4, I'd have to go 4 on both sides. Basically, you're kind of making a square. Other than these 3 points, the other points here are tough to get. I will tell you that there's another one over here. And I can tell that because it's 5 above the directrix. Now, this distance is kind of hard to say because I can't just count boxes, like this is 1, this is 2. But I can see that this is kind of a hypotenuse of a right triangle here. And this would be 3, this would be 4, and Pythagorean theorem tells me 3, 4, 5. So that distance is 5, and this distance is 5. So that is another point I can get, and then the same thing over here, up 3 over 4. Same thing with going, well, I shouldn't say. All right, but these are some of the points you could get. But like I said, these three are the ones I would really expect you to be able to figure out. Those, it's not always that easy. Drawing the parabola, make sure you do your best attempt to draw a curve. I know that this is not an art class, and oh, that was terrible. Me drawing on this tablet's not gonna, hold on. Me drawing on this tablet's not gonna be very easy. I'll do my best to oh god, this is terrible. I can write numbers okay on here, but I can't really draw parabolas very good. Wow, awful. You can do a much better job than that. All right, but that's so like those should be going through those points, but I don't want to waste your time with watching me draw pathetic parabolas. So given this parabola, determine a couple things. Does it open upward or downward? Well, that comes from the sign of the leading coefficient that we've learned in the past. And because this is a negative lead coefficient, the answer is downward. This would be a frowny face parabola. The reason why we're talking about that now again is because that's going to become relevant in the next couple of videos. So just remember that the sign of the lead coefficient, positive, arrows up, negative, down. Find the axis of symmetry. So the formula is x equals negative b over 2a. That's x equals positive 8 because here's your b term. And so negative b is like the opposite sign of b. So it's like negative 8, which is positive 8, over 2a, which would be 2 times negative 2 because your a term is here. And remember, the a, b, and c's are just the numbers, no variables. Like b is just negative 8, not negative 8x, because it's bx. And simplify this, we get 8 over negative 4, and it comes out to be x equals negative 2. So that's your axis of symmetry. And don't forget, it has to have the x equals. A lot of times people just say it's negative 2. That's not true. It's x equals negative 2. It is a vertical line. Part C, how do I find the vertex? Well, I can look in my calculator in a table, which is helpful, and there's tools that I'll show you in class how to do that. But the x value of the axis of symmetry is the vertex point. So I got to do f of negative 2, meaning I got to replace all my x's with negative 2's in my equation and solve for y, basically. Remember, this is the same thing as y equals. So that's negative 2 squared is 4, so negative 2 times 4. Negative 8 times negative 2 is plus 16 plus 3. This has come out to be negative 8 plus 16, which is 8, plus 3, 9, 10, 11. So the vertex is the point negative 2, 11. All right, and this is basically what we're going to be practicing the next couple of days, is drawing it from a focus directrix and answering these type of things. That's what we'll see in class tomorrow. And then we're going to get into a different way, given the focus and directrix, how can I get the equation? And that's going to require a special formula we'll learn in the next video. See ya.